Master Strategies with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken up a challenge question based on trigonometry. The problem which we are going to solve is cos x plus cos 2x plus cos 3x equals to 0. You can solve this equation and find a solution where x is between 0 to 2 pi. Okay, so work in radius. Some of you who haven't done this in radius, you may also solve at x between 0 to 360 degrees. Is that clear to you? So let's be open to both the units, as many of my subscribers might not have worked with radians. Perfect. Well, let me first thank all of you for posting brilliant comments and suggestions. This is your channel. Your questions are being answered. And if you really want to learn from me directly, send an email to globalmathinstitute@gmail.com. Contribute generously. You know, we are serving you free. For the last 15 years, we have 17,000 free math videos, right? And this channel is being watched over 80 countries. There are so many needy people who cannot afford expensive quality education. We provide it absolutely free. So every dollar you contribute counts. You can donate in denominations of 10, 15, 20, 25. And in case you want to be a regular supporter of this channel, send an email and discuss the possibilities. We can do a lot for you. Perfect. Now, let's look into the question itself. So, this question, as you know, comes from our subscriber who really wants to understand how do we derive the formula also and then solve the equation. So, we'll begin with the very basic concepts deriving the formula, right? So, as you know, cos of A plus B is basically equal to cos A cos B minus sin A sin B. Now, if I substitute A equals to B equals to X, then what happens, right? See how it changes. It becomes cos of X plus X equals to cos X minus sin X. Simple as that, right? Which you can now write at cos of 2x equals to cos square x minus sin square x. Makes sense. So that is the basic formula which relates cos 2x. Well, this is not the only one, right? So let us see the other forms of this particular formula which we just derived, which is cos of 2x equals to cos square x minus sin square x, right? You know, cos square x plus sin square x is equal to 1, and therefore we could rewrite this as cos square x minus, instead of sin square x, I could write this as 1 minus cos square x. And that gives us cos square x minus 1 minus, and minus becomes plus, it becomes cos square x, and that becomes 2 cos square x minus 1. So that is another formula which you can use for cos 2x. So already two of them are here for you. The third one, I'll leave it for you to derive, and which is cos 2x can also be written as 1 minus 2 sine square x. Perfect. So basically what you do is use this identity, the basic primary trigonometric identity, sine square x plus cos square x equals to 1 to get the other formula. Is that clear to you? Perfect. Now let's look into the term cos 3x. So cos 3x is basically you could write this as equal to cos of 2x plus x. No problems, right? Expand it using cos a plus b formula, which is cos 2x cos x minus sine 2x sine x. And now you know what is cos 2x, what is sine 2x. Well, sine 2x I'm not deriving here, but I'm writing for you. Sine 2x is 2 sine x cos x. Substitute and get the formula for cos 3x. Perfect, right? Okay, great. Let me take a break here. Just reminding you that in case you want to learn from me, send an email to globalmathinstitute@gmail.com. We can help you achieve your goals and objectives, right? You can be on the success path with Anil Kumar. Perfect. Also, remember, you can contribute, right? Those who are in Canada, they can actually do email transfer, and those outside can discuss with me the plan. I can provide you with the details. And we are looking for regular supporters also. Perfect. So, coming back to cos 3x. So, as you can see, we can write cos 3x is cos 2x cos x. Now, I'm really interested in writing everything in terms of cosine. So, cos 2x I'll write as 2 cos square x minus 1, and we'll multiply this with cos x, right? And here we have minus sine 2x, which is 2 sine x cos x, times sine x. So that gives us 2 cos square x minus 1. You could open the bracket this instance also. Let's do it, right? So we get 2 cos cube x minus cos x. Here we'll multiply and get 2 sine square x cos x. No problem, right? Great. So now we can take cos x also common, and we get cos cube x in this, but I'll prefer to write cos sine square x in terms of cosines. We get 2 cos cube x minus cos x minus 2 times, let's say 2 cos x, times sine square x is 1 minus cos square x. So that gives us 2 cos cube x minus cos x minus, open the bracket, 2 cos x, minus and minus becomes plus 2 cos square cube x, right? Great. So combining the cubes, we get 4 cos cube x minus 3 cos x. Makes sense? So we have the formula for cos cube x also, which is this, right? So now you know what is cos 2x, what is cos 3x. Substitute all these things in the given equation. So this equation, cos x plus cos 2x plus cos 3x equals to 0, can now be written as cos x plus 2 cos square x minus 1 plus 4 cos cube x minus 3 cos x equals to 0. Is that clear to you? So once again, cos 3x is 4 cos cube x minus 3 cos x, which we substituted here. Now this equation can be rearranged, right? So let's write them in order, right? So we get 4 cos cube x. As far as square terms is concerned, we got 2 cos square x. We can combine the cosines, which is minus 2 cos x minus 1 equals to 0. In the first two terms, you can take 2 cos square x common. We are left with 2 cos x plus 1 here, minus common 2 cos x plus 1 there. And now you can see that 2 cos x plus 1 is common. And that gives you 2 cos square x minus 1 equals to 0. Is that clear to you? So like we are just rushing through this solution, but you can always, pause or go slow or understand how we are doing it. Now we have two factors, 2 which are equal to 0 when multiplied. So clearly we have either 2 cos x plus 1 equals to 0, or we have 2 cos square x minus 1 equals to 0. Makes sense, right? So both will lead to solutions, correct? So let's move on to the next page. to really find the solution for these. So 2 cos x plus 1 equals to 0. So one is 2 cos x plus 1 equals to 0. The other one is 2 cos square x minus 1, right? So 2 cos square x minus 1 equals to 0. So the first one here gives you cos x equals to minus 1 over 2, right? And here, let's we get what? We get cos square x equals to half, or we get cos x equals to plus and minus 1 over square root 2. Is that clear to you? So those are the solutions. Now you need to write down all the possible solutions, correct? So you can use special triangles for these, and get the result, right? So we will give you answers in both radians and degrees, right, for the benefit of all the viewers. So it could be either intervals, correct? So the two triangles which you definitely need here is 30, 60, 90, right? So if this is 60 degrees, this is half, right, cos x. And if it is 45 degrees, you get square root 2. Correct. So when we say cos x is minus half, we also know that negative means apply the cost rule, right? Negative means quadrant 2 and 3, right? So we have this minus half means we have a solution in these two where this related acute angle is 60 degrees, correct? And therefore we have x equals to 180 minus 60, which is 120, and also 180 plus 60, which is 240 in degrees, correct? If you want to write this in radians, right? So radians is pi by 3. As you know, it is 2 pi by 3 and 4 pi by 3, correct? So in radians, you could write that as your answer. As far as plus minus 1 over square root 2 is concerned, all four quadrants, the angle being 45 degrees. So you can say x is equals to 45 degrees. 90 plus 45, 135. And then 180 plus 45, 225. And then you can add another 45 degrees to it, right? So we get 360 minus 45, 315 degrees, correct? Or you could also write as pi by 4, right? So basically, those are all the angles. You get the idea, right? So 1 pi by 4, 2, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Makes sense. So you see, it has many solutions, right? 4 plus 2, 6 solutions for this particular equation. So now we can say there are 6 solutions, right? We can write x as within pi by 4, so as you saw, pi by 4, I mean, uh, 3 pi by 4, 5 pi by 4, or 7 pi by 4, right? Those were for 1 over square root 2. You can say square root 2 over 2, right? And 60 degrees, which is 2 pi by 3, quadrant 2, and 4 pi by 3 in quadrant 3. So those are all the solutions in radians, and 6 solutions in degrees will be what? So x is 45 degrees, 135 degrees, 225 degrees, and 315 degrees, correct? Plus those 60 degrees, 120, and 240 degrees. Does it make sense to you? So very simple as that. We got all the solutions right here. And as you can see, one set of solutions are these, right? And the other set of solutions are, are these, right? So those are all the solutions for this particular equation. I hope you have understood the concept. Feel free to write a comment, share your views. If you like and subscribe to my videos, it'll be excellent. And don't forget to support us, as now it has become very critical, right? I've been supporting you with these free videos for a long time. Now it's becoming slightly difficult. Therefore, we are asking for help now. right? So it's the right time for you to help us out. Great. Next video is similar question, but see what we have done. We changed one thing and we made this as negative cos 2x. I will now like you to answer this particular question in any domain you want, whether it is 0 to 2 pi or it could be 0 to 360 degrees, right? Some of you can also try it in general domain, giving a general solution. That'll be great, right? So once again, feel free to send your comments and keep supporting us. Thanks for your valuable time, suggestions, and all the contributions. Thank you.